equal to 1.2, and then the alternative hypothesis made the not equal to 1.2, and then towards the end you said if we were to change the alternative hypothesis to mu being less than 1.2, how would we go from there?
Right, so how would we get the critical value?
Yes.
Is the question. Alright, so when we had this case, we had a normal distribution. Where would we, so this is mu, right? This is mu equals 1.2. For what sample values would we reject the null hypothesis?
Less than.
If reject it, if it's less than or more than 1.2?
Right. So it would be either a lot less or a lot more, and we would reject it in this case, right?
Yes.
Because we're just interested in cases where the mean is either much bigger or much smaller. Anywhere where the mean is actually different from 1.2, we would reject the null hypothesis.
Yes.
Make sense?
Yes.
Alright, so if our null hypothesis here were actually mu less than 1.2.
And then by looking at that, we know that it's two-tailed. So then whenever we're looking at the table, knowing that it's two-tailed also, like what does that give us?
Okay, so I forget what the actual numbers were, but let's think about this as a z-test for a minute, because we can easily remember numbers for a z-test. If you look up the critical value for a z-test, the z-value that cuts off alpha over 2, which is 0.025 in this tail. This is 1.96, and you can look that up in a table. Do you feel comfortable doing that?
Yes.
So what is this value?
Negative 1.96.
Yeah, negative 1.96, and we need to not have this be mu equals 1.2 anymore, but this is the standardized version of that, so we centered at 0. So after we've standardized, we'll reject if our z statistic is bigger than 1.96 or less than negative 1.96. Make sense? All right.
So this is with the critical value.
Yes.
Okay.
Now over here, if our alternative hypothesis is that the mean is less than 1.2, let's do the same thing. We'll standardize our distribution, get the distribution centered at 0. Where will we reject the null hypothesis under this distribution?
It's less than 1.2.
If it's much, much less, so we'd look over here where
Beyond the critical value, right?
values are much, much less. So the critical value here would be the value that cuts off alpha equals 0.05 in this one tail, right?
Yes.
So this value is going to be negative 1.65, about. Follow so far?
Yes.
So this value, when you look it up, it's just going to be, you're going to be looking up the area in one tail. So
Okay.
in the table, it will look like a positive number. You have to actually
we only
think
care about
about it
one
to
tail.
realize that you need to look at the negative value. Does that make sense?
Can you say that one more time, please?
When you look these numbers up in the table, just about always you'll get the positive number. There are some formats of the table where it gives you negative and positive numbers, but most of the time you'll look up a critical value, you get a positive number, and then you have to decide if it should be positive, negative, or both. If it's a two-tailed test, you're gonna look both in the positive direction and in the negative direction. If you have something like this where it's less than a value, then it's in the negative tail. If you have the opposite case where you have like mu is greater than 1.2 or something like that, you'd look in the positive direction.
And that's gonna give us our t value.
Well, here it's z because we're using z critical values, but this will give you the t critical value or the z critical value is the value you look up in the table. The other way to do this problem is using p-values. So you take your calculated z or t value and you find the probability of getting a more extreme z or t value. So that's a different approach, but it's the same in concept. So look through those slides from the end of last time for the z-test. Look at p-values and t-values and see if you make sure you can understand the correspondence between the two. I can go through that maybe in a couple of minutes if you want to come back to that, but I want to give other people a chance to kind of chime in with questions.
My question